Okay, so today we're talking about key features of quadratic functions. Last time we met, we talked about standard form. That's our ax squared plus bx plus c. We were able to find the axis of symmetry, the line in the middle, by using x equals opposite of b over 2a. We used the axis of symmetry number to help us find our vertex. We were able to find our y-intercept and use all that information to do a rough sketch of our parabola. So now we're going to add some what we call key features of parabolas that will help us out later on. We're going to talk about increasing and decreasing, inflection point, and concavity. Let's start with increasing and decreasing. Increasing refers to an interval for which the y values are becoming larger as I go from left to right across my graph. Before I explain that further, just a quick reminder that intervals are only written using x values. X values are the only numbers that can go in our intervals today. Well, except for range, but that's an exception to the rule. We'll talk about that later. So as I move from left to right, I'm looking for where my y values are increasing or going up. And in this parabola, it's the right half of my parabola, right? Remember, we're always moving from left to right like I read a book. And so this is the part of the graph that we consider going up. So let's take a look at what x values there are on this right-hand side of the graph. So the graph starts to increase the very moment it passes that axis of symmetry, right? So if I look at the x values on the right half of my parabola, I'll have my interval. So this starts increasing, or in other words, my vertex is where x is -1. Everything from there forever to the right, there should be an arrow on the end here because it's going to increase forever. I'm going to go on forever to the right. So I'm going to start where x is -1, and if I go forever to the right, I say that I am going to positive infinity. So my interval shows that, right? From -1, from where x is -1, on to infinity, meaning it goes forever to the right. Decreasing is the opposite of that, right? It's where the y values are becoming smaller as I move from left to right. So where is this graph decreasing? Every bit of the left-hand side of that graph, right? Everything from the far left, like forever left, up until I get to where x is -1. Everything to the left of the axis of symmetry. If I go forever to the left on the x-axis, I go to -infinity. So I start forever to the left, that's -infinity, and it's decreasing, decreasing, decreasing until I get to where x is -1. So my interval shows that. This means forever to the left up until where x is -1. So it's increasing from -1 to infinity, decreasing from -infinity to -1. Next, let's talk inflection point. An inflection point is a point on a curve at which the sign of the curvature changes. Now that means that the parabola changes from increasing to decreasing, or it turns and changes from decreasing to increasing. The point where it turns is called the inflection point. So on the graph that we were looking at before, this bottom or minimum point is the inflection point. That's where we change from decreasing to increasing. What's another word for that inflection point? Yeah, that's our vertex, right? So the inflection point and the vertex on a parabola is one and the same. Just a side note, at the inflection point or vertex itself, it's neither increasing nor decreasing. So yeah, that can't be part of our interval, right? That's why we use the round brackets. And concavity. Concavity is super simple if you know the terms opens up and opens down. If a parabola opens up, it's said to be concave up. If a parabola opens down, it's said to be concave down. Opening up, I can also say it has positive concavity. And opening down, I can say it has negative concavity. So this parabola, I can say it opens up, I can say it's concave up, or I can say it has positive concavity. On this parabola, I can say it opens down, it's concave down, and it has negative concavity. So how does all of this come together? Let's take a look. So we have a store, a local store that sells t-shirts, and their revenue model is shown by this equation, by this function. We can use the graph of this equation to answer a whole slew of questions. We want to find at what t-shirt prices they can sell or at what prices they can sell the t-shirts for to keep the revenue increasing. We can find out what prices they should not sell the t-shirts for because their revenue would decrease. We can find out what's the perfect price to sell the t-shirts for to get the maximum revenue and what that maximum revenue will be, right? What's the biggest amount of money they can bring in per month? And what t-shirt prices will give them no revenue at all? So let's take a look. Here's the graph of our equation. Notice that the x-axis is the t-shirt prices in dollars. The y-axis is the monthly revenue. So this is the amount that they can bring in. From 0 to 30, right, we want positive revenue. So nothing outside of the $0 to $30 range on the t-shirts is going to happen. And notice that our parabola on the y-axis, we're just going to say it goes from 0 to just above 1100. So where is this graph increasing? That's the left-hand side of the graph, right? Everything from where x is 0 to where x is 15. That's where our graph is increasing. That means their revenue is getting bigger and bigger and bigger. Wouldn't that make sense? They'd earn more money by selling the t-shirts for $15 than they would for selling the t-shirts for $5. So everything from 0 to 15 is where our graph is increasing. At what prices is the revenue decreasing? We don't want our revenue to go down. So what this means is maybe $25 per t-shirt is too much, and fewer people would buy those t-shirts. And even fewer would buy it if they were $30, right? That's too much money to sell the t-shirts for. So everything from $15 to $30 makes our revenue go down. So from 15 to 30 is where our revenue is decreasing. So what's the maximum revenue that they can make? Notice that our maximum point or our vertex is where x is 15. I can't exactly tell what our maximum revenue is. I know it's just above 1100, but there is a way for me to find out exactly. and that's by plugging the x is 15 into our equation. So if I plug in a 15, I get $1,118, and that's the maximum revenue or the most money that they can make. And finally, at what t-shirt prices do they get no revenue at all? Well, down here where y is 0, x is 0, right? They sell it for $0, so they make no money. Hopefully that would make sense, right? And over here at $30, that means that it's way too much money to sell those t-shirts for, so nobody would buy them and they would get no money. So at $0 and $30, they would make no revenue at all. All right, I think that's enough to cover today. Make sure to write down any questions that you have. Don't forget that the video rewinds and pauses, so if you need to do that to finish your notes or to go back and see an example again, make sure to do that for yourself. I hope you have a great day, and I will see you next time.